All right. Hi, everybody coming in. How's it going? All right. So as we go through, I'll do my best to kind of keep an eye on chat. But feel free to unmute yourself at any time if you're talky. I usually do a kind of an open question classroom. So yeah, students raise their hand, but I will take questions whenever. So if you have any questions, just let me know. Welcome. We'll get started in just a few minutes. We want to let people get here. But yeah, here we are. Anybody had any good sessions so far they want to share? Oh, somebody's in chat. Let's see. All right. Woohoo. Yep, if you notice in the chat, we've got that Visti 2022 link. You can go ahead and do a little selfie if you're at home and post that. Yeah, the keynote was great. I don't know if it was the same session. Was it the same session that we had? Okay, was broadcast. Yeah, that was pretty nice. Very inspiring. The keynote yesterday was really good too. I like that one. Yeah, been walking around a lot here. I feel bad for the people joining us virtually. There's no vendor floor. We got the floor this year. I'm getting all my swag going. Got about 2 more minutes. We'll let some folks in. See how many make it. If you're looking to join up, there's the bit.ly on the top of the presentation there, but we'll also paste that in chat so you can just click straight on it. If you're in the Sched page, Sched? Yeah, Sched, I don't know. I also have the 3 documents that we'll be going over today in there, but we'll also get to them as we go through the presentation, so you don't necessarily have to go in, open them from there. Those ones are saved as Microsoft Office things instead of Google Docs. The ones in the links are going to be Google Docs. The Google Docs are a little better. I went through and fixed some spelling mistakes, so don't judge me if there's some spelling errors. I'm a science teacher, right? Looks like just about another minute and we'll get started. Whoa, I accidentally scrolled. All right. Okay. We'll go ahead and get started. Hi, everybody. Hopefully, you know what session this is. This is our session on coding in your core content with Snap. So Snap is I'm going to get to that in just a second. But hi, welcome to Visti. Thanks to all of you that weren't able to make it in person for making it here. Are there a few of us joining in the classroom? Give me that thumbs up icon if you're joining us from the classroom. Give me, what's the other one? The clap. If you're joining us from home, the clap icon. Don't give me the clap, the clapping icon. If you're joining us from home. Oh, or if you're joining us from somewhere else. Let's see, what other icons are down there? I don't even remember. I have my screen shared. Give us a third one if you're joining us from a third location. Unspecified. There we go. I got somebody joining us from home. All right, nice. Okay. All right, so we'll go ahead and get started. Just starting out, hopefully you can see my screen. Yes, we got the diver there. Okay, so we're going to be taking kind of a shallow dive. I know that word shallow means I'm trying to think. Sometimes it means not so great, but in this case, we're going to take a little dive so that you can go deeper into this for success. So let's go ahead and start with who I am, and we'll go from there. So my picture here, not quite exactly my face, but there it is. Everybody was doing Bitmojis, and I wanted something a little different, so we got a pixelated Mr. Christensen there. So I'm Cody Christensen. I have 7 years teaching experience, 7.5 now, I guess, because it is December of this year. I've been teaching with Snap for 4 years. That's what we're going to be learning about today, in partnership with Microsoft Teams, which is a program that helps us to make sure that people who are maybe not as well versed in computer science have the chance to teach that to oncoming people. So there's volunteers that they work with. I'll talk a little bit more about that at the end. I would definitely recommend the program. If you're interested, you can go ahead, you can just Google Microsoft Teals, like the color teal, and then go through that way. I have some contact information for the gentleman that is the area representative for the Northern Neck. So if anybody's interested in his information, Earl Jefferson, there we go. Yeah, that's the person. If anybody's interested in his contact information, let me know at the end of the session and I'll get that for you. My email is right down there in the middle. And again, we got that bit.ly for this presentation. Looks like that's also up in chat. So yay. So if you're following along, that's where we are. All right, so let's go ahead and jump straight into it. So first off, what is Snap? So Snap is what we call block-based coding. Now, as I go through these presentations, if you're a first-year teacher or if you get flack from admin and they're like, what did you learn about? I put all the buzzwords in bold. So if you're looking for a buzzword, it's in bold. So block-based programming and problem-solving mindset, those are our buzzwords, but we're going to tell you what those mean. So first off, we're block-based coding. What that means is the kids aren't actually going to be typing in a bunch of code. They're not going to look like hackers or anything. They're going to be taking some blocks that do a specific thing and dragging them together to make it do a bigger specific thing. So kind of building on those things, like building with blocks. So it is easy to use and it helps students develop what we call a problem-solving mindset. So one of the things you need to know when you teach very basic computer science is that things do not always go as you plan, and that is okay. Students have a hard time with this one, at least most of my students. Very first off is they put their code in and they say, Mr. Christensen, it doesn't work. And I'm like, okay, well, let's fix it. But it's supposed to work. Well, let's find the problem. So with this, everything you try isn't necessarily going to work the first time. So that's helping them get that problem solving into their brain and get things going. So first off, Snap is very similar to Scratch. So I think some of us are probably familiar with Scratch already. So give me a thumbs up down there if you're familiar with Scratch as the block-based coding of choice. Oh, I don't see any thumbs up yet, but oh, there's one. Okay, there's a couple people heard of Scratch. This is very similar to Scratch. So I'm going to give you a little bit of background on what Snap is and how it kind of came to be. So what's the difference between Snap and Scratch? Now, if you're searching for Snap, it has to have that exclamation point because otherwise you're going to get Snapchat. Just as speaking from experience, that's what you're going to get. So both Snap and Scratch are block-based programs, and they are great tools for helping students learn computer science and coding. So Scratch is more directed at lower grades. If you've done a lot of Scratch coding, you'll notice it's kind of cutesy-wootsy, which is great and is definitely something that is useful, but it's a little, maybe as kids get into high school, they want something that's a little bit more grown up. So it's targeted at higher middle school, lower high school level, or even adults who are trying to get into this coding and don't necessarily want to see the cute little fox. I think it's a fox. It's either a fox or a cat. I don't remember. That's hanging out there. Oh yeah, we got a lot more thumbs up in the chat. I'm just checking. Okay, there we go. Yeah, a little cat. That's got me. So it's that little cat. He's cute. Snap also has a really cute little mascot named Alonzo. I don't know how to tell you what he is. We'll take a look at him in just a second. So the difference here, the people at MIT put Scratch together and they worked really hard on this. And then a group of people at Berkeley, UC Berkeley, went through and we're trying to figure out, well, Snap is great, but we want to be able to do all these different things and we want it to kind of work everywhere. So we had students that were working on computers, some that were working on iPads, some that were working on tablets, some that were working on just their phone. And they wanted it to be able to work no matter what device they had. And so they went in and tried to optimize it so that it would work on whatever a student would need. So students in my classroom, they use Snap on an iPad. Actually, most of them end up using it on their phones at home. I know this. I'm a teacher. I know this. I know that's how this works. But whoa, I scrolled down. There we go. I'm back. But it seems to work really well in all of those situations. So we'll be taking a look at that. The difference is Snap is just a little bit more robust in what you can do. Originally, the idea was Scratch didn't have a way to make your own blocks. So you couldn't create your own block and save it. But Snap came in and their idea at first was build your own blocks. So BYOB, and that quickly went away, but it was build your own blocks. And so they went through, put that together. And because this is all kind of open source coding, Snap went in and has now since added that to their library, their repertoire. So you can do those things in both programs. So I'm going to be speaking specifically about Snap. Now, you might wonder why I'm trying to use Snap over Scratch. Honestly, it's because I work with Teals and that's the one they taught me. I would probably use Scratch if I were doing that, but this is the one they taught me. So I know Snap, I'm comfortable with it. That's why I use it. Either one is a great tool. We're going to take a look at it today and see if maybe it fits your style better. All right, let me continue on here. So how can I use this in my classroom? So what I want to do is get a chance for people to use coding in an area where you think, oh, coding's not necessarily going to work. So with our education, there's been this strong move between project-based assessment, PBAs, or project-based learning, PBLs, kind of the same category, just depending on if it's a test or just how they learn. But with that push, which I mean, the push has been going on for, I don't know how many decades at this point, but we're trying to get that idea that learning doesn't have to be just the sit and get model, right? And we want to be able to have the students put something together. And a lot of times in a classroom, if you say, okay, we're going to do a project, students think, okay, poster, that's what I'm going to do. And that's where we are. Or they think, okay, PowerPoint, that's what I'm going to do. But I want to give them another option. So what I would probably try to use this for if I were a teacher outside of these areas is a choice for the students to do a project that's different than what they're used to. So yes, they could build a model. Yes, they can make a poster. I just want to add one more choice to that. So this coding process is for that one student in the back who really enjoys computer-based stuff, isn't really into working with their hands, doesn't really want to make a poster, doesn't really maybe necessarily want to work in a group. Just give them something that they could do and produce to make that learning happen. So with this, we can use this for project-based assessments. They create a way for students, I already talked about that. They create a way for students to express themselves without taking tests or quizzes. So with that block-based coding, this adds a choice to students and integrates technology into the learning process. If you're just getting here, all the buzzwords, they're in bold, just saying. So integrated technology into your classroom. If your advisor gets off after you about integrating technology, hey, we're working with coding in the classroom, I can do that. All right, so moving on. So how might I use this? So one of the things I wanted to make sure I did was not just, oh, here's the thing. I wanted to give you something you could actually use in class. So with this, many subjects have a difficult time incorporating these PBLs because there just isn't an obvious project for them to do. PE is kind of one of those ones that we have a hard time with, right? I just want to watch them dribble the ball. Why would I make them write a paper or do a project? Well, maybe there's something that we could work on here. So I want to give a few examples in most subject areas. I'm not going to say all subject areas, but I went through most subject areas to give you a few examples. So I've included 2 ideas in several of these core subjects. And what I use is called a design brief. So a design brief is kind of like a rubric. It's a little bit more open-ended. So it gives them a task that they want to try to complete and go on from there. So a design brief includes the assignment, the criteria that they have, so what they have to do in it, might be the rubric. And then it also includes needed materials and then any other notes that you might need. So let's move on to our example here. So I have the little scan code there that you can scan to get this paper, which also has 2 scan codes at the top. Hopefully you're able to scan your heart out and get this figured out. Excuse me. So looking at this, I'm actually going to go into the actual paper here if I can. There it is. And we're going to take a look. Most of these are little links that you can then be routed to. So I put together a few of these. I also stole a few of these. Not saying stole. These are public on Snap's website. And there's a few of these that students made. And a few of them do have a couple issues. So we're going to take a look at a couple of them. The first one I wanted to take a look at was, let's see if I can find my tabs at the top. Oh, the Zoom thing came down. Got to make it go away. Here we go. The first one I looked at was triangles. So this is a little coding thing that we could put together to help us with triangles. So if I click this little green flag at the top, all the code that we've had starts. It says, hello, I can help you with your triangles. And it says, tell me how long the shortest side is. So let's say we've got a nice equilateral triangle and it's equal on both sides. Illuminati confirmed, right? So we've got 3 for the first side, and I'm going to hit enter. I've got 3 for the second side. I'm going to hit enter, and I've got 3 for the third side. Now, what the program is going to do is a bunch of different things that the student would have had to program in. So let's see what the first thing is. It should tell us the perimeter. So does anybody know what 3 plus 3 plus 3 is to get our perimeter? Hopefully we all know it's 9, right? So it's going to tell us our perimeter, but it's also going to tell us if it's a real triangle. Ooh, that one's harder, right? So how do I know it's a real triangle? Well, I put in 3 sides, right? So shouldn't that just be a real triangle? Well, if 2 of the sides aren't as long as the hypotenuse, you don't have a real triangle, right? You've got an open box thing. So we're going to see if it's a real triangle, and then it's going to tell us which type of triangle it is. So let's go ahead and hit enter. Boop. That is a real triangle. The perimeter is 9. Hey, we got it right. And it's an equilateral triangle. Very nice. Okay, so I'm going to try that again with our favorite right triangle here, which is 3, 4, 5. To get those angles in correctly, because a squared plus b squared equals c squared, right? So I'm going to try 3, I'm going to try 4, I'm going to try 5. That is a real triangle. The perimeter is 12, and it is a right triangle. So look at this. Oh, it is also scalene because none of the sides are the same size. So looking at this, we've got a lot of complex code, but really, if you think about it, this is just what we learned. So let's take a look at what we have here. So we have our hello, this is the start. The kids don't necessarily need to program that to make this work. Our first one here is not. Whoop, I used a not because it doesn't do this thing. So if my side A plus side B is greater than side C, and whoop, I just messed up all my code. There we go, let me grab that side C. Grabbing. Aha. Whoop. So what we're saying is, sorry, basically, if 2 of the sides added together is not greater than the third side, then this code isn't going to work. So that's what the kids need to know and take away from this. So this is a really good way to check and see if they understand that. So the other one was our a squared plus b squared equals c squared. Now, unfortunately, there is not a squared block anywhere here in SNAP. So what I'd have to do is take my side A times side A, which means it's squared, plus side B times side B, which means it's squared, is equal to side C times C. I'll talk normal at some point. Side C times side C. So there we go. We've got a ton of different coding, which might look a little complex, but can you see how this might be used in a math classroom where they're talking about different shapes? But we can also make this a lot simpler. So I don't want to scare anybody because this looks a little bit too much. Let's see if I can do this. Maybe I can actually get to my links. Here we go. We're going to close that snap. We're going to close that snap. I'm going to leave. Yes. I'm going to take a look at another couple on here. So on this, I have a couple more examples that you're definitely free to check through as we go through. For English, I have a book report. This was a little game that I made on Ender's Game. So you fall down. If anybody's read Ender's Game, the enemy's gate is down, right? If you haven't read Ender's Game, highly suggest it. Just don't look into Orson Scott Card at all. Yeah, we'll leave it at that. All right, so we've got different sentence structure as well. So this one is actually an assignment that we did in my computer science class on sentence structure. So what you need to know about a sentence are the parts of a sentence and then how they fit together to make a sentence. So we start with something like a noun, right? So a noun is a person, place, or thing. And then we have a verb. So we've got a verb is the thing that one did. And then we have a bunch of different categories that we're also going to look at here. So when I click my space bar on this one, I believe this character's name is Abby. Abby's going to tell me a sentence. Now, it's not perfect, but it was put together right. So I'm going to go ahead and click again because I didn't read that last one. A silly TV angrily eats under a nice monkey. So yes, that was structured well, but there's a few things that are a little bit off. So let's take a look at how we put this together. So first off, what we did is we made a list of different things. The one that's up is our list of nouns. So a noun is a giraffe, a monkey, a boy, a girl, an elephant, a person, a woman. So all those nouns went into a big list. And so what we said when we put together a noun phrase is I need to pick a random item from my nouns, and that's my noun. But at first, I need to say the monkey, the girl. So we're going to take a random article. So that article goes at the front, followed by an adjective describing the girl, describing the woman, describing the person, right? And then adjective. I don't remember if I say the right words. Sorry. Sometimes I get a little mixed up. And then we follow that by our noun. That gives us a noun phrase. So I apply that, I click OK, and click on noun phrase. And that gives me my article right here, the big boy. So once I have that, I can start to put together the other parts of a sentence. So this one here, a prepositional phrase. Let's see, I'm not an English teacher, so I don't remember offhand what goes where. So for a prepositional phrase, we take a random preposition and then include a noun phrase. So let's check our random preposition and then have our noun phrase happen. Whoop. So under the small camera. So the big boy did something under the small camera. So what have I forgot? I've forgotten my verb, right? So a verb phrase, let's edit, is a random adverb with a random verb and then a prepositional phrase. So we've got our random adverb, our random verb, and our prepositional phrase. So I'm going to click apply, click OK, take a look at that. And if this is getting too complicated, don't worry, it doesn't have to be this much. Let's see if I can just click this to get it. My randomness here, stupidly sleeps through a nice monkey, which is a weird sentence, right? And then lastly, we have our sentence, which I can click on, which is taking that verb phrase and that noun phrase and putting them together. So the loud giraffe cutely screams around a loud person. Woohoo, we ended up with a sentence. Now, with this, you might also want to explore, hey, what's wrong with the punctuation here? Why is that T not capitalized? Could I code that to be capitalized? And yes, you definitely could. It might take a little while, but you could code that to be capitalized. So let's jump back to this one and see. I wanted to share a couple more examples in some of those harder to find ones. So math, English, so a tip calculator. Can I calculate 20% or 15% of my bill? In science, we actually did this year. We went through and made a cell model. I liked this one. Let's see if I can get it to come up. So the cell model is one where we took an animal cell and drew different pictures to make it fit into our section. So here, hi, I'm an animal cell. Click my parts to find out more about them. So this one is a little bit more easy. We did have to do the drawing initially to get them into the program. But if I click, I've got a few different things here. There's this guy here, which is the powerhouse of the cell. Anybody in chat want to share what the powerhouse of the cell is? Anybody remember? Powerhouse of the cell? How long does it take to spell mitochondria? Just a second. Yep, it's the mitochondria. Good job, Rob. So I'm going to click on the mitochondria and find out what it has to say about itself. So if I click, what's up? It's your boy, the mitochondria. You know me. I'm the powerhouse of the cell. And people call me that because I make ATP during cellular respiration. That is a little bit extra on top of just knowing what the mitochondria is to knowing what it does. Down here we have the Golgi. Some people call it apparatus. Some people call it body. And I'm like the post office of the cell. I package things up and send them where they need to go. So this is a little bit of a project that a student could put together. This one is far less complex than the other ones that we've been looking at. This one, we just had to bring the pictures in and then say what happened when they are clicked. When they are clicked, I wanted to move to the front layer and say those things. That's all it has to be. It doesn't have to be a bunch of moving. It doesn't have to be a bunch of calculations. It can be something as simple as say this when I'm clicked. If they're getting the point across, that is something that's working for them. Okay, moving on, I wanted to touch on some for PE especially here. And different languages. So with PE, one of the ones that we came up with was the rules of a game. So the rules of the game. So if you are learning a new game in PE, you need to be able to know the rules. And if I can make a program showing those rules, it seems to be pretty well worth it, right? So we set this one up. So this girl knows about badminton. I'm here to tell you about the badminton. It's played with a racket and a shuttlecock. Each match is the best of 3 game. The first player to 20 wins, but you have to win by 2. If the score is 29 to 29, first one to 30 wins. Boom. It's just a very quick understanding of the game. Now, what else could I do? This is something that I could definitely take deeper, right? So if I wanted to have 2 rackets and the shuttlecock move those things back and forth, that's something that one of those advanced students in your classroom, one of those higher performing students might be able to go in and do. Maybe make a game of what is basically Pong with those rackets. So again, this is not necessarily that difficult. A lot of says, and then we did some broadcasts. So broadcast in coding is just a way to talk to another sprite, another character. So in this case, I broadcast a racket. When the racket receives it, it just shows up. If it's clicked at the beginning, it hides. Really simple code that a student could use to show that they have mastered a subject. I did want to show off this one from foreign language because I had a lot of fun with it, honestly. This is a storytelling. Whoop. So one of the things that we do is put together a nursery rhyme project and just tell a story. So with this one, I wanted to do the 3 little pigs, but the sprites that were able to come up on Snap were a little bit limited. And during the day, I didn't necessarily want to download new pictures. So we ended up with a cute little story of 3 little pigs that I popped into Google Translate. So if there's a Spanish teacher here, please don't judge me. This is probably not good Spanish. Es no bueno. But here we go. We've got our lion and a little pig, which is penguin. No por el peo de, and I can't read it that fast. But he huffed and he puffed and he blew the house down. The penguin got sad and ran away. And there we go. There we go. And then click the green flag to try again. I don't speak Spanish. I apologize, but I wanted to try to get something in there that would really work. There's also one that's on here. This is one that I took from a student, which is a verb conjugator vocabulary. The verb conjugator was in English, but it's a vocab from Spanish. And so this student put this up and shared it online so that anybody could come on and see it. There are a couple bugs in here, which is to be a little bit expected. But the premise is there. So when we click, if we click on a certain type of thing, let's see, one of these worked. Was it the manzana? Oh, in the refrigerator. Where do you keep it? Wherever. Let's see. I don't, again, sorry. But they're saying different things that are related to their vocabulary. So a real good chance to add some vocabulary in there. All right, so now that we've looked at that, I have a sample design brief. So this is for the storytelling with that code. So my design brief looks something like this. And we have a section here where this is what I want the students to do. Now, with this, you could actually make this just an entire process. So for your project, I want you to be able to tell me these things. You can choose to make it in code. You can choose it to make it in wherever you want to make it. But in this case, this is specifically for code. So I start off with the background. It tells about a nursery rhyme, what it is. Our design challenge is what I want them to do. So I want them to use Snap to create a story animation. Your animation must display the nursery rhyme in its entirety and animate each line. So going through the criteria, what should they be able to do? I have the blocks that they should be able to do. This is the minimum. They can definitely go above. If a student comes to me and says, Mr. Christensen, can I also make the spider jump up and down? I would say, absolutely make the spider jump up and down. So down here, these are some of the blocks that they might need. And then down at the bottom here, these are notes for teachers. So the story probably shouldn't be too complex. Like I was saying earlier with the 3 little pigs, that might take a little too long. So if you want to just do 1 pig, that seems to work. So this is kind of the, hey, take this, go through them, see if any of these would work for a class like you in this setup. Let's go back over to that presentation. See if I can make it full screen again. Whoop, there we go. And we'll scroll down. Whoop, oh, too far. Maybe I should just click. I'm trying to be fancy and scroll. There we go. All right, so we wanted to look at how to use Snap now. So I have not shown you really how to use it at all because Snap is kind of a project or a program that you want to explore. So I want to run through a couple things on here, but it's something that you definitely want to explore on your own and just kind of look at each block and see what it does and kind of figure it out. There are tons of tutorials online, which I even have some up on my YouTube channel, which kind of help you through that process. But if you head over to snap.berkeley.edu, and Berkeley is spelled with 3 total E's in Berkeley, which I had the hardest time figuring it out. Or if you Google Snap Berkeley, it'll come up. If you just Google Snap, you're gonna get Snapchat. Just straight up, that's what you'll get. But Snap Berkeley is going to get you there. So this is what the program looks like on the home page. So first thing I did was I made an account for students. Anyone under the age of 13 would need to make an account with a class. So for you, you would set up a class in Snap and set that going. All the kids I work with are over 13. So it might be a little worth looking into before you start with the students. So I set up as Mr. C, CBHS, and I have a few lines of code on there. Looks like this when you first get in. And then if you click Run Snap, you get to a page that looks like this. So like we were looking at before, we have a stage and we have our coding area, and then we have our blocks that we can just drag in. So what does all that stuff do? So, like we said before, Snap uses blocks instead of basic commands to code for a computer program. Each block is assigned a string of code. So you can see the code on the back end. I don't remember exactly where you click, but the back end code is available for whatever you put in. So if you want to see exactly what it looks like, that is something you can do. But really, we're just looking at the blocks for now. We're trying to keep things simple. So this carries out things when they are either clicked or told to do so. So you can either click directly on the block or give the block a command that will tell it to do. Computers, as I tell my students, are stupid. They just are. No matter how smart your phone is, unless you tell it to do something, it can't do that thing. So these things have to be told what to do. If we want to put in a computer program, we got to tell it what to do. So every block is a short description of what it is. So our example here is move 10 steps. Hey, what do you think that block does? It makes it move 10 steps. It makes it move in the direction it's pointing 10 steps. Okay, so with our blocks, we break those down into categories, and those categories are separated by color. If you're colorblind, I do apologize. They are separated by color, but they are also in different categories. So the motion, anything you want to move. The looks, anything you want it to look like. Sound, if we want to do sound, we're not going to mess with sound today. The pen that you're using is to draw. Whoop. I went backward too many times. See, I got to actually bring a mouse with me next time. That's a mental reminder. There we go. Sorry, pen is to draw on the board if we want to draw anything on the board, and then we click those together to see what we can do. So let's see if together we can make this command that I have here at the bottom of the page. So I am going to escape out of there. We are going to go to Snap. Now I have downloaded the offline version of Snap, so this might be a little weird, just to try to help it run a little faster. The offline version of Snap just runs in your browser. So if you ever don't have internet connection, you can download it to your computer, run in your browser. It will work on an iPad, but it's not suggested. It's a little finicky. So what we want to do with this one is I just want to draw a square. So I want to draw a square. So I want to draw. So I'm going to find the category that goes best with draw. In this case, it's going to be this pen over here. So pen is definitely going to be good for drawing. All right. So I've got clear. Well, I don't necessarily want to erase right now, but I might later. So I'll drag that over here. I've got pen down. Let's see. If I'm thinking about a pen, I have to put it down to draw, right? So I'm gonna use that one. And then I've got pen up, right? So pen up is at the end. I'm done drawing. I want to bring my pen up. So these are some blocks that I need. Now I could change my color. I could change the hue. I could change the pen size. I could stamp. I could copy something and stamp it. I could do a fill. I could write hello. There's a few different things on there that we could play with. I want to stick with the simple. We're going to go with pen up, pen down, and clear. Okay, we're sticking with the simple. All right, I want to draw a square. Well, if I click pen down, it doesn't draw me a square. So I needed to put the pen down and then move. Move is going to be in motion. So I'm going to move a few steps. Whoop, boop, boop. So I'm going to put the pen down and I'm going to move 60 because 10, honestly, on here, 10's a little small. We're going to move 60 steps. And then I'm going to bring my pen up. Hey, we drew a line. Look at that. We drew a line in code. Very cool. All right, but not what I wanted. I wanted a square, right? So let me grab my little character here, my little turtle sprite, and drag him back. And I'm going to click that clear button to get rid of it. Okay, so I've got my screen, and I'm going to try to make this happen again. So to draw the other side, I have to turn, right? Oh, look, there's some turns up here. Okay, so I've got turning. Now, if you're anybody in here a math genius, how many degrees am I going to have to turn to make that angle on the corner of a square? Anybody in chat want to help me out with that one? How many degrees am I going to have to turn? I know you know it. I don't want to like patronize. But what's the degrees of an angle like this? Somebody knows. Hey, Beth was first. Good job, Beth. So we got 90 degrees there. I'm going to go ahead and put that in. 90 degrees. Let's see. So now it's going to turn 90 degrees. Now I want it to do that more than once. So I want to like take control of this and say, I want you to do this a bunch of times. So in this case, I want to grab a control block. So from up here, I'm going to grab control. And if I look, I've got a nice little repeat block. Now, if you look, it's the alligator. Nom, right? So we've got this little alligator that I've got to put something in there. Oh, I can just put all of this code in the alligator's mouth. Nom. So how many sides does the square have? It's 4. I'm not gonna make you figure out how many sides the square has. It's 4, and I'm gonna hit repeat 4 times. Hey, actually, this pen up could have been after. It still looks good. Look, we drew a square. Isn't that cool? That's pretty cool. So what about a triangle, right? I did it 4 times for this, so I can just change it to 3 times, right? Oh, well, Mr. Christensen, it didn't draw a triangle. What do I have to fix? If you're a math teacher working with angles, that's definitely a great way to do that. So if I'm going with a triangle, I've got to turn whatever the outer angle of a triangle is, which is going to be 360 divided by 3, which is going to be 120. 120. Let's see if 120 works. Bloop. There we go. We got a triangle. It's on its side, but we got a triangle. Okay, so that is our introduction here. I want to make sure I'm still good on time. Whoop, yes. Okay. So I think we're pretty much to, what do I have next? Here we go. We're to saving. So with saving on Snap, it's a little tricky and the kids have a hard time with it first off. So when you have created your masterpiece, you need now to save it and share it. So I'm going to jump into the online version of this, I got to have my own here. Whoop. The not offline version, and show you how to save if I can get it to come up. Because saving is a little weird. So what you're going to do is in that top left-hand corner of the screen, there should be a little piece of paper. I tell the kid the piece of paper means it's a file. So let me drag a couple blocks down here just to make sure we're making something happen. So I click on that paper and I've got a few options. So one of them is just straight up save. And I can click straight up save. I haven't saved anything there yet. You're going to have a big blank in the middle of here. I have hundreds of projects that I've worked on with kids. So I'm going to save this as a test project. And click save. And yay, I have test project saved. Now, that doesn't mean I can share it yet. Because if I click here and copy my URL, it's just going to take whoever gets it to Snap. It's not going to be my program. So I want to share my program. So if I click on that again, instead of save, I'm going to click save as. And I have my test project, but I want to click share here. So it's one of the little finicky things that I've found with students is that test project here in the middle has to already be shared. LMNOP, Yes, I sing the song every time I have to go through the alphabet. I don't think I'm the only one who does that. You see, okay. So we're going to highlight it here. And then instead of clicking save, we're going to click share. Boop. Are you sure you want to share? Yeah, I'm sure I want to share. And there we go. It has been shared. Now, if I wanted that to show up on Snap's website, if I wanted to be able to share it with everybody, I can click publish. So clicking publish is going to put this on Snap's website. It's going to be searchable. It's going to be findable. It's kind of great, but maybe it's not done. And I don't want people to see it yet. So I'm not going to save it yet. So we can do that. After I saved, notice what happened to my URL up here at the top. So instead of just being snap.berkeley.edu, it's now has my username, my project name, it's got a ton of numbers in there, and boom. This, if I were to copy and paste this somewhere, anyone would be able to go into my project and see what is there. Now, if they're not logged in as me, they can't save it to my account, but they can save it to their own. So as a teacher, this really works well because they can send it directly to me. I can show them the changes they need to make and then send them to do it on their own account, because I can't change things on their account because I don't have access. I do have access because I get their emails and stuff. But there we go. All right. So I know that is not enough to say that you are an expert in Snap. It's just not, because it takes a little bit more. So what my hope is that you will play with this a little bit, and even Scratch. If you would like to play with Scratch, I would say they are both wonderful tools. Scratch is a little bit more first-timer friendly than Snap is. So just get on there and play with it. One of the things I forgot to show you is that if I can't remember which category a block's in, I can click on this little magnifying glass right here. And I remember, the block I'm looking for is point. And if I search for point, every block that has the word point in it shows up on my screen. So that is definitely handy if you can't remember which category your block, the one you're looking for, might be in. All right, let's see. Whoop. And then I forgot to add the word questions to this slide, but this is my special thanks end of presentation slide and any questions we might have. So first off, I wanted to thank Microsoft Teams, because they're the ones who taught me how to use this. If you are interested in getting that contact information, just shoot me a quick email. My email's on the top there. I think it's also on the Visti page. You can just shoot me a quick email and I'll get you their information. I would highly suggest it if your computer science teacher is motivated. If your computer science teacher is not motivated, it's kind of a drag. And it is something that you apply for, and it's free through Microsoft if you qualify. So definitely reach out if you're interested in that. I got to thank VectEasy for the pictures, just saying. It's a nice place to get some pictures that you can use. There are a few free ones. Not all of them are free, but they're free with attribution. And then lastly, Colonial Beach High School is where I work. I want to thank them for letting me come today. And yeah, all right. So any questions? I'm going to jump into chat and check for questions, and we'll go from there. All right, let's see. Whoop. Oh, I accidentally dragged my toolbar down to the bottom. There we go. Oh, thank you so much, Deb. Let's see. Does Snap have a library of sprites? Yes. So I forgot to show that one. Let me jump over to Snap and show you the sprite library. So Scratch obviously has a sprite library there, and then you can draw your own. Snap does as well. Let's see, I got to be on the online one, otherwise it doesn't work. Whoop. So if you jump into File and look there, you can import your own pictures. If you click Import any picture on your computer or iPad, you can just import it straight in. And then down here, we do have costumes. So if you click on costumes, these are costumes for your sprite. There's also, if you're on the stage, you get backgrounds. This does take a minute to open. This is probably the thing that consumes the most time in my classroom because this takes forever to load on my smartboard. But you'll notice we have Abby, and this is Alonzo. I forgot to tell you about Alonzo. He is the little Snap mascot. I don't know what he is. I honestly don't know what he's supposed to be, some kind of alien. But we've got airplanes. A lot of these pictures are going to look familiar because they pulled from the same library that Scratch did. Some of them are a little different. A lot of them are going to look almost exactly the same. So they're all there. And then when I'm ready, I can just click import on the one I want, and it comes into my program, and I can change it out. And I also have a few of them that have animations. So let's see if we have a Jamal walking here. Where'd Jamal go? I'm scrolling too fast. But we've got a few that have animations for people walking, and you can pull in all the ones you want and then just cycle through the costumes as you go. Okay, let's see. Whoop. Are students required to create accounts? Yes, they will need their own account to save. They can, what they do in my school is use their school email address, because if they use anything else, they're gonna forget it. Yes, I think they have to create an account whether they're in elementary or in higher levels. Even if they're above 13, I think they do have to make their own account. Let's see. Whoop. All right, you're welcome. Oh yeah, if Scratch is blocked, yep, jump into Snap. It's through UC Berkeley. It shouldn't be blocked anywhere. So yeah, woohoo. All right, any more questions before we let you go? Okay, again, if anything comes up or if you're just interested in finding out more, my email's on there. I'm not on Twitter anymore. I deleted it, I'll be honest. There we go. All right, thank you so much. Don't forget to jump on for your next session, and hopefully